Evaluate the following indefinite integral. So here we have the integral of the vector valued function defined as 7 cosine of 7t times sine of 7t. We have secant squared of 5t. And last but not least, we have 1 minus t multiplied by sine of t squared minus 2t dt. So, to make this a little bit easier for us, let's just begin by separating this out component by component. We have the f of t component, we have our g of t component, and we have the h of t component. So let's think about this component by component. So we can rewrite this as the integral of 7 cosine of 7t sine of 7t dt, and that's multiplied by vector I, plus the integral of secant squared of 5t dt multiplied by j hat, plus the integral of 1 minus t multiplied by sine of t squared minus 2t dt k hat. So we've got a big general antiderivative here. But if we think about this component by component, it's going to be easier to work with. So here we go. Let's integrate each component of our vector separately, and then we'll put everything back together. So we are integrating each component to get us started. So to begin, we have the integral of the f of t component. So here we have the integral of 7 cosine of 7t multiplied by sine of 7t dt. So this is not a general antiderivative, but we do recognize that this is a trig identity. So let's recall our double angle formula. So the double angle formula for our trig identities. So I want to let k be any scalar, some real number. So we want to recall that sine of 2kt is equal to 2 times sine of kt times cosine of kt. So this is what we have above. We'll just simply need to manipulate this. If we divide both sides by 2, we have an equivalent form. We can say that sine of 2kt divided by 2 is equal to sine of kt multiplied by cosine of kt, which looks exactly like the integral we're given. So here we go. Let's rewrite our integrand. So this becomes the integral of 7 multiplied by sine of 2 times. So this would be 2 times 7t, all divided by 2 dt, which of course we can simplify. This is equivalent to the integral of 7 halves sine of 14t dt. And now this is a general antiderivative. Woohoo! This is going to integrate to minus 7 halves cosine of 14t divided by 14 plus c, which we can simplify. We of course know that 7 goes into 14 2 times, leaving us with the beautiful final answer of negative 1/4 cosine of 14t plus c. So here is the general antiderivative for our f of t component. So next, we need to move on to our g of t component. And let's give ourselves plenty of room. So our g of t component, the integral of g of t dt, in this case is defined as the integral of secant squared of 5t dt, which fortunately is a general antiderivative. We, of course, know that this becomes tangent of 5t divided by 5 plus c. And there you have it. Here is the general antiderivative for the g of t component of our vector valued function. And last but not least, we want to integrate the h of t component. And here the h of t component is given to us as 1 minus t multiplied by sine of t squared minus 2t dt. And so to integrate this, we're going to need to use u substitution. So here we go. Let's go ahead and let u be t squared minus 2t. And now we need to differentiate with respect to t. So we have du dt is equal to 2t minus 2. And dividing both sides here, we're solving for our differential dt. So dividing both sides by 2t minus 2, we are left with du all over, and I'm going to rewrite this as 2 multiplied by t minus 1. I factored that common 2 out. And that, of course, is equal to dt. So here are the substitutions that we need. And we can plug them into our integral. So we now have the integral of 1 minus t multiplied by sine of u. And dt is now replaced with du all divided by 2 times t minus 1. Now we still have too many variables to integrate, but looking at this binomial in the denominator and the numerator, we realize that if we simply factor a negative out of one of them, say we'll do this with the numerator, if we factor a negative 1 out, we are left with minus a minus 1 plus t, which matches the term in our denominator. Woohoo! So we can cancel this. Just don't forget about your negative out in the front. So this cancels to a minus 1, allowing us to rewrite this integral as negative 1/2 times the integral of sine of u du, which is a beautiful general antiderivative. So this becomes negative 1/2 multiplied by minus cosine of u plus c. So the negatives cancel each other out, leaving us with 1/2 multiplied by cosine, and we'll replace u with our u substitution. So this will be positive 1/2 cosine of t squared minus 2t plus c. And so this is the general antiderivative for that h of t component. And we are officially ready now to evaluate that full vector valued function. So plugging everything in that we just found. So actually, let's remind ourselves, what have we just integrated? Well, we were asked to evaluate the general antiderivative of 7 cosine of 7t times sine of 7t. And we use that double angle formula for this portion. We had secant squared of 5t, which was a general antiderivative. And then last but not least, we have the component 1 minus t multiplied by sine of t squared minus 2t dt. And plugging everything in, we are left with the beautiful final answer. The general solution, or general antiderivative for our vector valued function is minus cosine of 14t all divided by 4. We have tangent of 5t all divided by 5. And last but not least, we have cosine of t squared minus 2t all divided by 2. And don't forget, that's plus your arbitrary constant vector c. So this is our beautiful final answer, the general solution or general antiderivative of our vector valued function.